All right, Algebra 2. In 13.4, we talked about graphing the first of our trigonometric functions here, which was a sine wave, and now in 13.5, we make a short little jump into graphing cosine waves. What you're going to find is that cosine waves and sine waves are almost the exact same thing. In fact, their shape is, in fact, identical. It's just a question of where you start and how you get there. So let's begin with our parent graph here, just y equals cosine of x. Then we're going to try to keep this section relatively short. We're just going to graph two variations on that, but we need to start with our basic one right here. So just like we did with sine waves, we're going to begin with just an x and a y table here, but since you guys learned kind of what the shape of a sine wave looks like in 13.4, I think we can go a little quicker through 13.5, and we're just going to go with what we consider to be our 5 most basic angles here within the x column. We're going to begin with letting x equal 0, and then from there we're simply going to go every pi over 2 units. Now the reason we're going by pi over 2 has to do with something called the period of both a sine and a cosine wave being equal to 2 pi. And this year, that's not something we're going to change in Algebra 2, although if you guys take pre-calc next year and you start doing more graphing of different kinds of sine and cosine waves, that might change. But I'm going to keep adding pi over 2 each step along the way. Another pi over 2 gets me to pi, plus another pi over 2 is going to be 3 pi over 2, and one more addition of pi over 2 here is going to get us to 2 pi right back where we started. And now, it's a simple matter of taking these 5 angles, putting them in for x, and evaluating your cosine value. Now, it's not a bad idea, anytime you're getting the hang of this here, guys, to draw yourself a quick little unit circle diagram right here. And remember, guys, that the cosine of any angle on the unit circle is given to you by your x-coordinate. Now, technically, cosine is equal to x over r, but if we're on a unit circle here, where your radius is equal to 1, that means that you can kind of ignore this because you're just dividing by 1, and we'd be better off than just saying that cosine is simply our x-coordinate. Again, if you're on a unit circle with a radius of 1. So the first angle we're looking at is 0 radians, which gets us to this point right here. Now, what I'm hoping we're pretty comfortable with by now is that this ordered pair I've just put in red is the ordered pair 1, 0, and cosine is your x-coordinate. So again, since this is 1, 0, and our x-coordinate there is 1, the cosine of 0 radians is again equal to 1. And now let's just go to our next quadrantal angle, guys, right up here at pi over 2. That one is going to get us the ordered pair of 0, 1, straight up due north. And once again, cosine is our x-coordinate there, so the x-coordinate at the point 0, 1 is now 0. So that gives us a cosine value of 0 at pi over 2. Moving around the horn here, guys, we get right over here to pi radians, 1/2 circle from where we started. That is the ordered pair -1, 0. Once more, cosine is your x-coordinate, which in this case is -1. And hopefully you guys are starting to see the patterns right here. We move right down now to 3 pi over 2 with the ordered pair of 0, -1. Cosine is that x value once more, so there's another 0. And lastly, we'll go back to 2 pi, which you'll notice is right where we started, and once more, your x-coordinate is 1. So there we've come up with 5 ordered pairs now for y equals cosine of x. Let's plot them and see what we have going on here, guys. Just a reminder that the way I've set this graph up, I know those decimals are a little bit goofy here, everybody, but this value right here of 6.28, which is right here, that's actually equal to 2 pi. That means that this value right here is pi, and then this guy right there is going to be pi over 2, and this one right here is going to be, let me think about where I'm going to be here, is going to be 3 pi over 2. Okay, so let's plot the 5 points we came up with. 0, 1 puts us right here. Pi over 2, 0, we have an x-intercept there, and then pi -1 gets us right here. At 3 pi over 2, we go back up to 0, and at 2 pi, we're all the way back where we started there at +1. And I'm going to say again, guys, the shape of a cosine wave is identical to the shape of a sine wave. It's just a question of where you start. So let's try to get this as accurately as we can in our notes. What we have right here, guys, is a peak value at 0, 1, and your cosine wave should actually be horizontal as it passes through that point. But as it passes through an x-intercept like this, your slope should be either -1 or +1 here at 3 pi over 2. And again, it's horizontal as it passes through its peaks and its troughs. So the shape of my curve should probably look something like this, and then it levels out and curves back up a little bit. We're not simply connecting the dots and having this Charlie Brown zigzag pattern. So there's another part of the curve and another part. Now, I'll tell you right now, I have a lot of students get a little bit lazy at this point and draw me something that looks like this. And if you did that on a test, guys, I would take off half a point. The whole point of this is that we have a peak maximum value here of 1. The curve never goes above that y value right there. So you want to make sure that you draw this properly, so that this curve levels off and then comes back down just a little bit past it. And if I wanted to continue the graph, you can kind of see what's going on backwards here, guys, I hope. And if not, you could go back to your floating red dot here and say, okay, at -pi over 2, cosine, my x value is 0. All right, and if you can see the pattern, good for you, but at -pi, we're at an x value of -1. At -3 pi over 2, we're up here, back to an x value of 0. And then at -2 pi, we're right back where we started here. So drawing the rest of this cosine wave, I'd have a curve, and then it bends upward and stays upward, and then it kind of curves downward after that. And that, everybody, is actually not just 1, but 2 cycles of a full cosine wave. So I'm really hoping that you guys recognize the shape and size and scope of this graph right here. It really does look exactly like what we did with sine in 13.4. The big difference here, guys, is this. When we drew a sine wave in 13.4, you don't have to put this in your notes, guys, but hopefully you have it already from yesterday. When we did sine of x, we started at a intercept right here, and your sine curve went up and then came down and then did that, and of course it continued on over and over again, but it started and it ended at an x-intercept. I should say one cycle started and ended. Here, we started this graph not at an x-intercept, but at a peak value of 1. And after one complete cycle, that got us back to another peak right over here. Let's talk about the same few things that we talked about in section 13.4 with this wave right here. Domain, guys, a word we struggle with and have all year. The set of all x values that you can put into a function right here and get a real result out. Well, just like sine, you can put any number you want into the cosine function and you'll always get a real result. Another way to look at it is this graph goes infinitely far to the right and infinitely far out to the left. As such, your domain is all real numbers. Really, that symbol right there, which I didn't draw very well, means real numbers, but if you want to put the word numbers at the end, that's fine too. Range is now the set of all y values that you can get out of this function. So for range, I'm really looking here in the y column, or I'm looking vertically at how far this graph travels. And just like the sine wave, this thing seems to have a minimum value here at -1 and a maximum value here at +1. And if you really understood what was happening here on the unit circle, with cosine being your x-coordinate, you can see how this x value of any one of these points is never going to get bigger than +1, and it's never going to get smaller than -1. So our range, just like it was for sine, is -1 is less than or equal to y, which is less than or equal to +1. Okay, couple more things to consider right here, guys. The amplitude of our wave. That is always a measure from the midline of your graph up to a peak here. So what I just drew there in red, that looks like a 9. Sorry, that's supposed to be an A for your amplitude, and on this graph, that amplitude is 1. And the last thing that I alluded to earlier here, the period. How long does it take this graph to repeat itself? And that's really the distance, guys, where we just talked about from peak all the way over here to another peak. And that is the period of a sine or a cosine wave, and in this graph we can see that that period is 2 pi. Again, if you take some more math classes in the future, you're going to start messing with the period a little bit, which makes things quite a bit harder. But for us this year, and certainly right now in 13.5, we're going to keep that period nice and simple for you guys at 2 pi. All right, everybody, and what we have right here then, hopefully you guys can put this in your notes right here, this is your parent graph for what a cosine wave looks like. They're all kind of based off of that. So as I said, that's kind of the normal one. I'm going to give you guys two variations on that, and here's the first one here. So I call this one transformations. Y is equal to -2 cosine of x. So what do we have here, guys? You've got your cosine function, and then that is being multiplied here by -2. So we're really going to set this problem up the exact same way that we just did, with an x column and a y column, and we're still going to pick the same 5 values for x that we had before. 0 radians, and then pi over 2, followed by 1 pi, then 3 pi over 2, that was an ugly 2, and lastly, we're going to end this thing here at 2 pi. And every time I make a table here, it gets wider on the bottom than it was on the top. Okay, that's about as much as we need. Now, everybody, we're going to do the cosine of whatever x is first, but then when we get done with that result, we are going to multiply whatever we got for the cosine by -2. So it's just a question of order of operations, and even though there is no T for trigonometry and PEMDAS, this is kind of like looking at something inside of parentheses. We do the trig first, then the multiplication. Now, once more, you probably don't have it memorized yet, but here's just a quick small unit circle diagram, and let's start at 0 radians, which is right here. Cosine at 0, that's our x coordinate, that's going to be a 1, and then we multiply 1 by -2 to get -2 for our first y value. Okay, at pi over 2, we're now moving straight up here. Cosine, our x value is 0, and 0 times -2, still 0. Gotcha. Let's move over here to our third angle now, pi. Cosine, the x value is -1. This gets interesting. And -1 times -2 is going to make +2 for our y value at pi. Onto 3 pi over 2, we're straight down here. Cosine is our x value, which is 0, and 0 times -2, still 0. And 2 pi gets us right back where we started there, guys. Cosine, x is 1 there. 1 times -2, -2. So let's plot these 5 points and see what we see. 0, -2 is going to be right there. Pi over 2, 0, got it. Pi 2, right about there. Now, I'll tell you guys, just like in the last problem, as soon as you draw your first 3 points on a cosine graph, if you've done it according to this method we've talked about, these 3 points should be collinear just about every time. But as soon as we get to the next point, 3 pi over 2, 0, now obviously we're dealing with a nonlinear function. And then 2 pi, -2, right back where we started. So again, trying to draw our cosine wave with a nice curve to it here. Remember, it kind of levels off as it gets to peaks and to valleys here, and it should have some nice symmetry to it, guys. Looking maybe something like that. Wasn't very good, but like that. That's kind of what it should look like here. I'm going to just kind of follow my pattern backwards here. That should be an intercept, then a peak, then another intercept, and then another trough right over here. So I usually draw these better from left to right than I do from right to left. Okay, and that is kind of 2 full cycles then of a cosine wave. Now, what I want you guys to notice about this, the last graph that we did, the parent graph of a cosine, starts right here at a peak, and we ended it at a peak as well. But this graph, we began with this point first. That's a point that we call a trough, T-R-O-U-G-H, and it ended at a trough as well. And why did the first graph start at a peak, but this one started at a trough? Because of the negative coefficient out in front, which told us that we were going to flip this graph vertically like that, guys, over the x-axis. So that peak, which would have been right here, now got flipped down over the x-axis to become a trough. Let's knock out those same 4 questions real quick, everybody. Domain, the set of all x values. Once again, that one is going to be all real numbers. You can go as wide as you want with this graph here. Range, How tall and how low is it? Minimum value down here at -2, maximum value up here at +2. So -2 will be less than or equal to y, which will be less than or equal to 2. Okay. Amplitude. We're going to talk more about this in the next section, 13.7, everybody. The amplitude, then, is always going to be the absolute value of this number right out here in front. So let's go ahead and write that out. Amplitude is the absolute value of -2, which is +2. Even though that a value is negative, the amplitude is a distance from kind of this midline up here to a peak, and that's why we always take the absolute value of that number. You wouldn't say that the amplitude is -2. And last thing, guys, once again, the period is the horizontal distance between one full cycle of this graph. We started it right here, and we ended it right here, and once more, the distance between those two, that's your period, is going to be 2 pi. It'll get harder next year, but for now that stays pretty well the same. All right, guys, so those are two graphs that kind of give you some information about what a more or less basic cosine graph looks like. I've got one more I wanted to do with you right here, and then we'll be done, I think, with this one. Now, this always bothers people right here because of the order of things. We've been given y equals -2 plus 3 cosine of x. Most of the time, people prefer the trigonometric term to come first and then the constant that's added or subtracted. Well, if that's what you like, fine. Let's just rewrite it. The 3 cosine of x is positive, so I'll just begin with that. 3 cosine of x, and then we have a -2 that comes at the end of all that. Okay, that wasn't so hard. So don't be too startled here, guys, if you get a constant in front of your trigonometric function. Just think of it as addition or subtraction that comes at the end. Same 5 angles today, guys. 0, and then pi over 2, followed by pi, and then 3 pi over 2, and lastly 2 pi to end this whole thing. You'll notice, guys, I don't have a graph here already. I actually had one, and I got rid of it because I want to show you guys how we'll try to do that on our own here in just a moment. Okay, so again, probably a good idea to have a little unit circle drawn, and we've got our floating dot, which I'll put right here at 0 radians to begin, and let's see what we can do here. The cosine of 0 radians is 1. That's something we have to remember, guys, that cosine of 0 is equal to 1. Always, always, always. We have kind of a hard time remembering that from time to time. So the cosine of 0 is 1. We multiply 1 times 3. Remember, this is multiplication, and that gets us 3, and 3 minus 2 is going to give us a 1 for our first y value. Okay, from there, let me clean this up just a little bit. Let's move on now to pi over 2, which is going to be our next value for theta, or in this case, x, our next angle, pi over 2. Now, once more, here we go. Cosine there is your x-coordinate, which is 0. 0 times 3 is 0, and minus 2, we're going to end up with -2 for that y value. Let's keep going around the horn now. At 0, cosine, your x value is -1. So -1 times 3 is -3. And -3 minus 2 is going to bring us all the way down to -5. Okay, that's the lowest we've been here so far today. 3 pi over 2 is right here. Cosine is your x-coordinate. That's 0. So let me clean this mess up real quick. Okay, so cosine at 3 pi over 2 is 0, times 3 is 0, minus 2 is -2. And again, ending right where we oh, that was weird. Why did that move there? Okay, interesting. Gotcha. All right, guys, so we move that point right there. Gotcha. And now we're at 2 pi. Cosine there, your x-coordinate is 1. So 1 times 3 is 3, and 3 minus 2 gets us to 1. Okay, so when it comes time to actually create our graph, here's the way I would do this if I were you guys. We don't have any negative x values, so I really don't need the second or the third quadrant showing up in this graph at all. I really just need the first and the fourth. My y values, though, you'll notice, are mostly negative. What I really want you to focus on is that the max value is right here at 1, and the minimum value is right here at -5. And that probably tells me that most of my graphs should actually be centered here in the fourth quadrant, more so than in the first. Okay, so I'll go ahead and make this graph with the space that I have. And what I always do is I go as far out to the right as I can with as much room as I gave myself, and that's where my one period of this graph is going to end. And our period here is still going to be 2 pi. Then I do the best I can. It certainly doesn't have to be perfect, but I try to backfill that space. However long I gave myself for 2 pi, I try to draw a little segment in the middle, and half of 2 pi would be 1 pi. Half of 1 pi, sure, right about there, is going to be pi over 2, and halfway between pi and 2 pi will be 3 pi over 2. Now, trying to get the spacing on my y-axis right, you really don't have to spend all day on this, guys, but I can tell already that if I wanted this to be accurate, I don't think I did a great job. Let me tell you what I usually think of first if I'm trying to get my graph right. The distance on the x-axis that we have set up, guys, from here, I wouldn't put this in your notes, guys, but just follow along with me. From here to here, from 0 to pi is approximately, not exactly, but approximately equal to 3, because pi is actually 3.14. This distance then, let me switch colors on you here, guys, from the origin all the way over to here, that is roughly 6. Because if pi is 3.14, 2 pi is 6.28, sorry. So that means, everybody, that what I have right there in green, oh, could I actually steal? I suppose I could. I could take this. Now, you guys would just kind of do this mentally right here, but I could kind of flip this guy around a little bit and say, okay, that distance right there along my y-axis should be a distance of about 6. And that means that if I really wanted to get this right, and again, you don't have to. I'm not going to take off if your graph isn't perfect here, guys. But that means that since I'm going all the way down to -5, I could just eyeball here and say, okay, if that's about -6, then right here is about -5. Now, that's more time and effort than you need to put into this, guys, but I just wanted to show you how you could do it if you wanted to get it just right. I don't think that many people care that much about it. I won't take off for it if your scale is off a little bit, and on all your homework and tests, a graph will be given for you. So, okay, we don't need to dwell on that too much. Now, from there, I'm just going to kind of guess here where I'm at. I'm going to say -1, and then -2, and roughly right about here would be -3, and there's -4, and that gets us to -5. We also need to go up on this graph to include +1. So I'm just trying to match my spacing in some of the other parts. Okay, let me get rid of a lot of this junk here, guys, because I don't really need it anymore, and it's kind of in the way of my graph. All right, and you can go away, and you can go away, and I think this last green thing here, delete that. Okay, and we're in pretty good shape here, guys. Now, one thing I like to do, you'll see me do more of this in the next section. Our maximum value here is 1, so I like to draw a little dashed horizontal line right there at 1. You guys are probably taking notes on lined paper right now. You can kind of utilize that fact. The blue lines on your paper, of course, are parallel. I do the same thing down here at -5, which is my minimum value, and we've also got this middle value that showed up twice here of -2. So I'll draw that one in here also. All right, and with that in mind, we probably have a good sense for what this graph should look like. We start at the ordered pair 0, 1, which is right up here, and then we go to pi over 2, -2, and the fact that I drew those little dotted lines makes this pretty easy to locate. We're at pi -5 right there. We're at 3 pi over 2, -2, and we're at 2 pi 1, which is located right there. And there's the 5 dots I was looking for, guys, so I'm going to try my best to draw a curve here that looks like this, and then bends upward at the very bottom, all right, and then does this, and then bends the other way and hits that point, and then comes back down after it hits it, and I'd make it do the same thing back over here on the left, and that would be one cycle here, everybody, of our cosine wave. All right, so that -2 at the beginning is kind of your middle line right here, the starting point, and you'll notice this thing went up 3 units and down 3 units from there. Let's knock out the same 3 questions real quick, guys. The domain, once again, this thing goes forever to the left and forever to the right, all real numbers. Your range, the lowest y value that we hit was -5, The highest one we got was 1. So we would say that our range is -5 is less than or equal to y, which is less than or equal to 1. Okay, your amplitude is the absolute value of a, and a is the coefficient of your sine or cosine, which in this case is 3, guys. And the absolute value of 3 is just 3. That's measuring the distance from the center line all the way up here to a peak. That's your a value. And once more, third time in a row, the period hasn't changed. The distance from this point all the way over here to the very next peak, that is going to be 2 pi as well. All right, guys, hopefully those 3 examples give you a pretty good sense of how a cosine graph is constructed and how it works. Again, once we get into 13.7, we're going to start to do more with transformations, which we started to do in this example right here, and hopefully we have a good solid foundation underneath us before we move on to those harder problems in the next section. So good luck, everybody.